Hi, welcome to Complex Engineering. So in this video, I'm going to talk about train control management system, which is also named as train control monitoring system. Now, what is this system? Already we have spoken about different subsystems which has been used in our train. Like for example, we already talk about bogie system. We have already talk about ventilation air conditioning system, braking system, and then traction converter system, high voltage system, coupler system. So all these are the different subsystems which has already been used in our train, right? Now it is very important, all the subsystems should operate properly, right? If it is not operating properly, specifically I am emphasizing APS, I mean to say auxiliary power system, which is also known as SIV. Most of the people often call it as SIV, static inverter unit. So static inverter unit, or can say traction converter unit, so these are the most important component. And then ventilation air conditioning unit. So these are the most important components, or can say subsystems, which is very responsible for the passenger comfort, right? So without extending the topic that much, I in simple word I mean to say, it is very important to monitor all the activities which is being done in the train. So we have, for that we have TCMS. TCMS stands for train control management system, which is also known as train control monitoring system, which is very responsible for monitoring all the activities being done in the train, for the supervision also, and for the management also. Like TCMS is a computerized system which is monitoring and supervising, managing all the activities being done in the train, right? So as I was discussing about the subsystems, we have bogie, we have brake system, we have coupler system, we have in our train SIV system, in our train ventilation air conditioning system. So these are the different subsystems, right? And train driver need to communicate with all this subsystem for the operation of the train, right? So how that train driver would communicate with all this subsystem? With the help of TCMS, right? Let's suppose I'm giving this example, and then again we would get back to this definition of TCMS, what actually the TCMS is, right? Sorry for that. So as I said sometimes back, imagine we have VAC, ventilation air conditioning system, right? Again I am repeating the definition of TCMS. TCMS is responsible for controlling, monitoring, managing, and for supervising all the activities being done in the train. So first consider this term controlling, how TCMS is controlling all the activities being done in the train. Imagine train is running on the main line and the temperature of the train increases all of a sudden, right? So we need to control the temperature, right? So how that train operator would control the temperature of the saloon? By giving command in the TCMS, right? So that train operator would give command in TCMS, due to which TCMS would give signal to VAC system, ventilation air conditioning system, and ventilation air conditioning system would operate in such a way that the internal temperature of the saloon area would get reduced automatically. So in this way, what TCMS is doing? TCMS is controlling the temperature inside the saloon via VAC. Again consider this example, the temperature of saloon falls down automatically, right? Now again we need to increase the temperature of the saloon. So what train driver would do? Train driver would again give command in TCMS for VAC, due to which the temperature of the VAC would get again increase. Train driver would give, train operator would give the command in TCMS. TCMS would give signal in HVAC, and then HVAC would reduce the temperature of the saloon. So in this way we have understood so far that TCMS is able to control the thing which is being happen in the train. With the help of TCMS we are able to control the temperature inside the saloon. We can control the interior temperature of the saloon with the help of TCMS. So in a very simple term, so far we have understood that with the help of TCMS we can control the temperature of VAC, due to which saloon interior temperature would get control, right? So this is the first example of controlling. Now second example, as I said, TCMS is responsible for controlling and for monitoring. TCMS is also monitoring whatever is being happen in the train. Like for example, imagine a camera of a particular car is not working all of a sudden. So how train driver would get to know about that camera? In the page of TCMS, train driver need to go to the page of the camera. There would be some sound, or can say there would be like some indication through which would appear on TCMS, and through that indication driver would get to know the camera of that particular car is not working properly. So in this way, from this example, one thing which is clear enough is that TCMS also monitoring the things which is being happen in the train. If camera is not working all of a sudden, then it would pop up in the TCMS and driver would get to know about that. Now, as I said, controlling and monitoring. Now third is the supervision. We can compare monitoring and supervision, like both are the same thing so far. We can compare both of them, monitoring and supervising. And then management. Now management system, what do you understand? Like for example, how TCMS is able to manage the things being happen in the train. Like for an example, if multiple failure is happening in a train, as I said sometimes back, I had given the example of like a VAC. When temperature is going up, then the train driver is giving command to the TCMS, due to which temperature is coming down, right? In this example, I said that train driver is giving the command in TCMS, due to which the temperature of VAC is getting down, falling down. Now here one thing that we need to understand, this was to understand the things, right? How TCMS is able to control the thing which is happening in the train, right? Now in TCMS, there is like different option, manual option, automatic option. If you are like clicking on automatic option, then each and everything would happen automatically, right? If thing is happening automatically, then we can say TCMS is able to manage the entire thing which is being happen in the train. Imagine again this example of VAC. The temperature of the VAC is going up, right? So there would be sensor which would sense the temperature of VAC, and then temperature sensor would give command to TCMS. It is just like a closed loop system. Temperature sensor has given the command to the TCMS. Now TCMS has got to know that the VAC temperature is increases all of a sudden. Now what TCMS would do? Now TCMS would again generate the signal, and it would transfer the signal to the VAC unit, and VAC unit again reduce the temperature, right? So in this way, again I am repeating the same example so we would understand the thing in a very better way. As I said sometimes back, imagine we are traveling in a train and the interior temperature has increased all of a sudden drastically, right? Now there would be sensor which would sense that temperature, and that sensor would give signal to the TCMS. Now TCMS has got to know the interior temperature of that particular saloon has been increased drastically. Now what TCMS would do? Now TCMS from its side generate the signal and transfer that signal to the VAC unit, and VAC unit, what it would do, it would reduce down the temperature of that particular interior of the saloon of the car, right? So in this way TCMS is able to handle the thing by itself, right? So in this way we can say TCMS is able to manage the thing, right? So from this example, from this few example, whatever example I have given to you, we can also consider this one more example which I have seen often frequently happening in the train. Are TCU, and TCU stands for traction converter unit, and then ACU stands for auxiliary converter unit. Sorry for that. Auxiliary converter unit and TCU, most of the time TCU, or can say ACU we can consider ACU, auxiliary converter unit, or apart from that we can name it as APS or ACU. Both are the same thing. APS, auxiliary power system, and then TCU, ACU is the auxiliary converter unit. SIV, ACU, APS are the similar thing. So imagine this example of SIV. SIV is not working properly. SIV is isolated, right? How I would get to know about it? SIV is isolated, or there is some fault in SIV. APS, there is some fault in APS. How I would get to know about that? Rather than considering APS or ACU, it is better to consider SIV for the better understanding. SIV stands for static inverter unit, which is very responsible for like low voltage system. I already have spoken about all this thing in our earlier video, but for the better understanding, again I am giving like little bit idea about SIV. What SIV is? SIV stands for static inverter unit, and it is responsible for developing the low voltage supply, like 3-phase 415 volt supply, then 220 volt supply, 110 volt DC supply. Now what's the requirement of all this supply? Obviously 3-phase supplies, we use it for like compressor and for the condenser of the VAC, and then 110 volt DC signal, it is a hardwired signal, and for providing the DC supply. And then we have single phase supply for the socket charging and all in our trains. So these are the auxiliary supply which we basically use for like different purposes, right? So imagine there is a fault which is happening in our SIV, or can say APS, better SIV, fault happening in the SIV. So how would I get to know about that there is a fault happen in the SIV? Through the TCMS. I would show you practically how TCMS looks like and what are the different like whatever examples I have given you. Like I have given you the examples of VAC, I have given you the example of SIV, APS, right? I would show it practically so you would understand about it in a very like efficient way, and you would get to know about the thing in a very clear way, right? So there is a fault in SIV. How would I get to know about that? I would get to know about that with the help of TCMS. In TCMS, this fault would pop up. See, there is a fault which has happened in the SIV. Now what I would do? There is a fault in the SIV. TCMS is showing it to me. Now how is that possible? Because our TCMS is monitoring all the things which is happening in our train. That's the reason as SIV is showing us there is a fault in TCMS is showing us there is a fault in SIV, because TCMS is monitoring all the activities being happen in the train, right? Now TCMS has got to know there is a fault in SIV, and TCMS is showing me the same thing, there is a fault in the SIV, right? Now I need to rectify that fault. Now for rectifying that fault I have two options. Either I can give the soft command, or with the help of, like for example, I can reset the circuit breaker through the hardwire signal. Soft command with the help of software, or hard command with the help of CB or hardwire signal, we can call it as, right? Now I would like give command in TCMS to reset the APS, right? When I would give command in TCMS, then with the help of that command, that's the soft command, APS would get reset. So what I am doing over here, I am giving command to the TCMS, and TCMS is further processing that command to the particular subsystem. I hope you have understood the example what I mean to say. SIV fault has happened in the SIV has like TCMS is showing that fault in the SIV. It is like that fault, which whatever fault has been happening in the SIV, that fault is like popping up in the TCMS, and I'm giving command in the TCMS, and with the help of that command that fault is getting rectified, right? So in this way TCMS is monitoring all the activity being done in the train. So far we have understood about the TCMS. What is TCMS? Again I am repeating the definition of the TCMS. TCMS is a computerized system which is very responsible for monitoring and for controlling and for managing all the activities which is being done in our train, right? Now in this video, this was the basic introduction about the TCMS. In our upcoming video we would understand like what's the function of TCMS equipments. TCMS is a computerized system. So far we have got to know about that. TCMS equipments, we would discuss about TCMS equipments, like for example we have BRIO, and then basic remote output system. We have it is a computerized system. Obviously in computerized system we would get hardware and software. In hardware we have like BRIO, right? We would discuss about in our like further topic. And then equipment functions, what are the different hardware and software equipments has been used, we would discuss about that as well. And then at the last we would discuss about architecture of TCMS. TCMS architecture, like how TCMS has been designed, we would discuss about that same in our upcoming videos.